Hi, and welcome back. My name is Mark, and we are solving the Christmas tree exercises, Advent of Code 2015, day 18. I created the whole mumbo jumbo files. Okay, not files, but one file which was included in the library, so it will be included in this library that we created. And we have to come up with some sort of solution to the first and to the second part of that given day. I didn't create those things. I will do it quickly. I will try to do it quickly. So we need an 18 prod and a 18 test. Getting there. So we should save those, and we will see what is the input and what should be the output. Cool. Description. Day 18. Like a GIF for your yard. After the Million Lights incident, the fire code has gotten stricter. Now, at most 10,000 lights are allowed. You arrange them in a 100 times 100 times 100 grid. Never one to let you down. Santa again mails you instructions on the ideal lighting configuration. With so few lights, he says, you'll have to resort to animation. Start by setting your lights to the included initial configuration, your puzzle input. Hashtag means on and a dot means off. Then animate your grid in steps, where each step decides the next configuration based on the current one. What is it called? Automaton? Or something like that. I do remember in a few weeks ago, Choding has been creating a few. It looked crazy. So each light's next state depends on the current state and the current state of the 8 lights adjacent to it, neighbors. Lights on the edge of the grid might have fewer than 8 neighbors. They missing ones always count as off. For example, in a simplified 6x6 grid, the light, this is the example, neighbors 1 through 8, so this is the B, and this is the A 1 through 8, so these are the neighbors, and this is just a neighbor identification example. But this is a, well, that's interesting. I thought that we should do, whatever, we will do a dynamic thing instead of 100 times 100. I mean, it would be a bit of a big example, but yeah, we will do it this way. So the test should be rather this. Yeah, and should be happier. Yeah, it is. Sorry for the quick change of windows. So the state a light should have next is the state a light should have next is based on its current state, okay, plus the number of neighbors that are on. Wow, okay. So these are the rules. So it's pretty much like a Game of Life, or what was the other one? Brian's Brain? Brian's Brain Tree? Brian's Brain? Yeah. I mean, that's another automaton as well, and it has some rules. Not that much, as you can see. The whole description is not that much, but we will see. So these are the rules, and yeah, that's it actually. So we should have an input of this thing. So that's a 100 times 100 input. Looking good. We should override this thing here. Hopefully looking good. And we are interested in how many lights are on after 100 steps. So we are interested in the, what is it called? Evolution, because it's somewhat a modeling of cells. Yeah. So we should do something like enum, no, cell should be alive and dead. That's kind of it. We might create a type as well, which should be a hash map of this thing, and in that case it doesn't have to be, what is it, a fixed size slice, because we can dynamically create it, and we should, I don't know, implement a new for that. Ooh, what is going on? I mean, it's not bad. So we are generating a new hash map. We are going through the lines and we are enumerating it. So this is a line index. No, this is the line index. This is the line Y and X, whatever. We don't even care if we are mirroring it by the diagonal stuff. It really doesn't matter, because we are calculating the amount of things. We should create a function which should get the name. Come on, man, I want to think myself. Product. This product is the iter2, and we need the std product. What is it? It's not the. So it's not that. Give me a second. So it should be not compr env. No. Is there iter on std? Yeah, looking better. No, not looking better. Yeah. We had it somewhere. Prod. Duct. Stud iter. Jesus. What? 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 But. Okay. We do have another product as well here, which is the. What is it? The iter2's product. And I'm not sure about this thing yet here. So we should. Yep. Get neighbors. Function. Get neighbors. Looking good. Yep. Yeah, looking good. So this thing, the cell, should be dereferred. So we should add some derives here. Debug, partial equal, all of those. Why not? Yeah, looking good. So we are returning with the neighbors, and we have to do some assumptions, because based on the current state, we should calculate the -1. Oh yeah. So we should calculate the next state. So there should be a function which is. What do you mean second? I don't want your. What? No. Function. Evolve, which should get a grid and return with a grid. And we should apply the rules which are described here. So if the neighbor is alive, I mean the cell is alive here. So if it's on or alive and 2 or 3 neighbors are on as well, yeah, maybe we should do some Yeah, whatever. Alive neighbors is, yeah, I mean, it's looking good. We are counting which ones are alive. If it's dead, only one case is when it can come alive, but we can create a new grid. So the question is, how can we use this thing here? And the amount can be, I don't know, what is it? The evolution, or what is it called? Oh boy, never mind. I won't remember that thing, but we should read this thing. We should evolve and mutate this hash map, and we should yeah, looking good, looking good. So we should. So if we solve this thing, it should be after the fourth. There should be 4. These example 4 lights were on. It should be 4, probably. Okay, it was already good. But we should know what is after 100 steps here. So we should read the prod version of the first. I mean, we should read the prod version of the text. We should parse it into a 100 times 100 times whatever, but it's dynamic. And we should compare it to this number, whatever that thing is. So we should run the tests. Maybe we should ignore all of these interesting things, but we might do it later. We should do refactorings as well, but I don't really care. I just want to go to the next year. Okay, so it's 4. Okay. So it's 0, but it should be 4. We are calculating the next one as well, but it's just failing. Okay. So first exercise 18. Let's see what's in the test again. So 18 tests. So it should be this. I'm not sure about this thing. Oh yeah, it's just some finicky stuff there, but those should be the correct inputs. Let's see how the parsing works. So if the cell is this character, it should be alive, else it should be dead. It should be pretty much correct at X and Y, and it shouldn't be bad if it's X and Y and this is not. So we are going through the lines, and yeah, it should be the Y because the first line is the 0 at Y, so it should be incrementing within this bigger loop. A good question, what's going on? Get neighbors, it should be this thing. What's that? So we are going to the surrounding things. We are not reading the exact thing, but everything else. And we are pushing everything, and if it's not on the table, so we cannot unwrap it, it will be by design and by default a dead cell. Okay. So if the neighbors are 3 alive, that it's looking good. Maybe let's see it once again. So we shouldn't be maybe, but that's interesting. We should print the grid here, and we will see. I mean, hopefully it will be pretty close to 2-dimensional things, and we can read it somewhat clearly. And we should just run this thing, and we will see if it's pretty much the same or not. Oh yeah, what has been described. Yeah, it's not the same because yeah, so we should implement the debug trait for the cell, which should be this thing. Let's run it once again and hope. Yeah, we don't need the default debug something, and the import looks. Hello? Who is you? Let's see once again. Maybe it will be the less bad thing. Almost. Yeah, and we are not interested. Yeah, we should implement debug for grid as well. There should be this function-ish stuff, and we should go over the whole string, and we should do some what is this? What? Self dot keys? Are you ma? We should. What is going on? The error definition should be here. I'm not sure. What is your issue? Hash map is not defined in the current. Pardon? Excuse me? Okay. Hash map is not defined in the current trait. Then what is this? What do you think? Only traits defined. Oh yes. Yeah. So we can only apply trait or overwrite trait implementations if the trait is written here or the struct is written here, and we don't have neither of those here. Then we will do a function which should do pretty much the same, but can't you just come on? I mean, we will leave it to stringify grid. Come on. Now you should be the smarty. And I mean it's looking good. So position, why not? So we will do this thing instead of printing every single time like this, and we will just stringify the grid. Okay, expected hash map, found hash map, cell random state. Okay, so we need a grid reference. What's your issue here? Function defined here. Okay. Thank you. Let's run it once again, and I just wanted to see the output just like I would expect. Come on, man. Wait, what? So in the example, which is the test, 18 test. Wait, that's, oh Jesus. If you're copy pasting things, you should pretty much do it correctly, not just like me. Let's run it once again. Yes. I mean, it has been looking a little bit better. I'm not sure about this states, but why not? Okay. Okay, it's that amount. Let's run this thing as well, and we should have some calculations with the tests here as well. We don't want to print that thing. Let's run it again. We started to run a lot of tests, which is not bad, but we should not do that every single time. So it was 1061 like this, and this should be the result as well. Yay! Second part. After 5 steps, what's the difference? You flip the instructions over. Santa goes on to point out that this is all just an implementation of Conway's Game of Life. Wow. At least it was, until you notice that something is wrong with the grid of lights you bought. 4 lights, 1 in each corner, are stuck on and can be turned off. The example... What? Oh yeah, these ones. But... So... we should overwrite this thing, and we should ignore... what is it? The corners, whenever the evolution happens between the states, I guess. And we need 5 steps with the second solution. There should be 7. What's going on with these numbers? Okay, after 5 steps, which is this number, there should be 17 here, and we are interested in this thing. So let's calculate the second thing, which should be pretty much the same as here, but we want to do some evolution, which is a bit specific because we wanted to ignore whenever this thing happens. So we should copy paste things and not refactor things because we do not care. Evolve what is it called? Expect corner. And are the corners on in the tests in the prod? That's interesting. What happens if given your initial configuration, but with the if the 4 but it's what? I mean, those should be always on, so we shouldn't even do the evolution there. But we yeah. So we shouldn't do that thing. So if the position, is the first or the last, it should be alive, and we should continue. I mean, we don't care about all of the other things. Looking good. So we should do pretty much the same here. And yeah, that's it. I mean, evolve, but expect the corners. Let's see if the test is good. I mean, with the 17. And we are getting back the correct missing or mismatching value, which will give us the 36th golden star. Okay. What is 8? What do you mean? Cell alive count. So it is 8 here, or it is 8 in the tests. I mean, in the example test. Let's wait a little bit. Okay. Yeah, it Seems interesting. Looking good. So no, it's in the tests. So 195, which is the exact expected example here in the second thing. So what is the thing here? So let's rethink this. You flip the instructions over. Santa goes on to point out that this is all just an implementation conveys. Yeah, as late it was until you notice that something's wrong with the grid of lights you bought. 4 lights in each corner are stuck on and can be turned off. But what do you mean? So this is the initial state. Oh. But okay, never mind. So we should run the first exercise second with that string and with 5, and this thing should be here. So it should be that thing, and we don't want to overwrite it because it probably changed. Yeah, it's not that. Man, come on, man. It should be the same. You should not changer. Now it's 10. I'm not sure if it's better or not. So it's the example, which is 205. So this is still the example, and I'm not sure. So after 5 steps, the this example. Okay. So yeah, we should go back and see what's going on. If we would print, yeah, the grid like this. We should do it after or before? After and before. Looking good. Looking good. There will be a lot of output. Oh yeah. Ooh. Yeah. Big chunk of output. And looking good. It's kind of changing. Hey. It's doing things, which is not bad. It's calculating all of the things, but it's still 10. And actually I'm interested only in this thing. So I should not calculate this thing. And yeah, it can be empty. So again, let's see with a smaller set of things. Let's see if it looks like the same or not. Ooh, it's... What is going on? But even the corners are not staying on, is it? What? But there should be... What? Excusez-moi? What is going on here. So we should read the grid based on this content. And actually we made no modifications yet. Interesting. Let's run it once again. There should be only one output. Maybe? Yeah. And this is not the same as I provided, or is it? No, it's looking eventually. Oh, it's rotating it, question mark. No, it's not. It's not even the same. Exercise second, read grid. But bro. But bro, what? So if this is that, is it rotated or not? Who knows? Can I do this thing here? So it should look like this. And it definitely should start with an on, even if it's rotated or not. But it is in the first row. There should be. What is? Wait, what? I mean, it's not even. How much thing is that? 14. What? Give me a second. What is going on? What? So this is 7 times 7. 1, 2, 3, 4, 5, 6. Pardon? What is going on? Give me a second. So this grid so this evolve should overwrite or create a new cell for every new something, and we shouldn't change the position. Ooh. Wait. Oh yeah, we are inserting one. Never mind. Okay, question mark. What's going on? Get neighbors. Yeah, X and Y. I'm not sure about this X and Y things, or Y and X, but it shouldn't be. Oh boy, it's not 99. I mean, come on, man. It's grid dot keys length, because it's not always 100. Oh jeez. As I say, Stefan, I demand using same formatted inputs and outputs. Obviously it won't keep this thing always on up, because it should not be the corner. I mean, we cannot read this position. Okay, let's rerun this thing, and hopefully the corners will be the same, and we will get another number. Numero. It's still 10. Should it be -1? So whenever we have one, yeah, -1. Give me a break. Maybe we should just calculate this thing here. Okay, let max is this, and we might say this, that, this, and that. Not better, but it is. Looking good. Maybe. Not bad. But not good neither. And what is going on? So let's, yeah, why not? Why not? We can print stuff any day. Yeah, we should actually run only the tests, and we should see if the output of it looks good or not. Ooh. Why can't you? Can I say this without getting angry and such? We'll see. If the splits debug is a split or not. Not really. Can we get lines? It will be an iterator again, but yes. Jesus. Yeah, this is looking great. Really great. Thank you for the needle. Thank you for the test. What is going on? So, okay, we should copy this thing. We should create one test. I mean, one additional test that if we would call the evolution of that set of things, evolution is a lie. So this is the string that we are interested in. We should, okay, again. So we should create a grid from this thing. Ooh. And we are in dead cells. Please no. Grid expected evolve. No. We want to call it only once on this grid and evolve without the corner, and the grid we are interested. So this is a thing that we should grab by this value, and it should be let corner 1 or top left, whatever. What's your issue? This is not a... Okay. Is it better? Nice. So the corner 1, oh, is it? Yes. Okay, looking good. So all of these things should be alive, or I'm not sure if we can do this comparison between... Oh, this is a cell. Oh, yeah, that's... Never mind. The hash map contains cells. Ooh, this is good. So the error with this thing. Oh, looking good. What is the assert equals, so the grid's length should be 25. Why? ¿Por qué? 5 times 5? But no question mark? What? This is not. Yeah. Drink less. I don't know what you're drinking, Yomi Copilot, but this is not correct. This is not right. So we are not in. So give me a second. So when we did this hacky thing, so the max is not the keys length, but so the grid. Ooh, I will do some dirty stuff. So we should not calculate this thing, but the square of that thing, because it's, I don't know, 2 times 2, 4 times 4, etc., etc. So we need the square function, whatever, of this thing as I64. Can I do that? Am I allowed to do that? Unsafe block? Sheesh. Why not? Please? What's your issue? Unstable, yeah, and we have to run it as unstable. Come on. What? Okay. Come again. So we've been here, so we should do something else. Can we do this? Square root of this thing. It should be this thing. Please. -1 as sub I. Oh, okay. As I32. Is it corretto? As I32. What's your issue? So F64. I can do that. But I should do the subtraction here. Yes, it's no longer necessary. What's your issue? Come on. I32. So we should do this thing. Maybe the tests will be correct. Maybe it will be 17, and maybe we will get back a number. But just maybe. Okay, the corners are good, or should be good. So this is the first. But meh. Why? I'm not sure about this thing. I'm not sure. Maybe we should just do the setup corner, and maybe we should do the whole crazy thing after every step. Can we do this? Because we should just set up the thing here, and this way it should be just an evolve. And we should set up the corners with a mutable reference to the grid. Should it do it before or after that? That's interesting. I don't know. We should see. What's your... Oh, there's no such thing anymore. Man. I'm starting to getting a little bit upset. ¿Por qué? ¿Por qué would you do that? It's even less. Maybe we should fill the corners before, because we are calculating the next one. What is... Yeah, we should do this thing. Shut up. And this thing. Yes. Coming back here. So we should not print things because it kind of doesn't work. We should set up the corners before doing the evolutions, and after that as well, because it might just modify the things in a bad way. Let's see if it's getting closer to 17. Yeah, maybe. No, it's 4. Looking good. Greed, evolve. What are we doing wrong? What is going on? Match cell alive. But give me a second. So we should change this as well. I don't know. But man, I got brain damage. But you flip the instructions over. Hopefully it doesn't mean that I have to change these instructions. Why is the wording that ambiguous? Santa goes on. Just let's look at Conway's life. I mean, it should be so. If the cell with fewer than 2 live neighbor dies, what? Any live cell with 2 or 3 neighbors survives. Any dead cell with 3 live neighbors become alive. I mean, a live cell. All other live cells die in the next generation, and everyone says that. It's pretty much the same. I mean, it should be the same. So what's the matter? So if it's dead, won't change unless it's 3. It's alive. It will stay alive if the neighbors are 2 or 3. But so the setup corner means we should do the max and the zeros, and we should always set or upsert these ones. So if this was sufficient, oh yeah, I know, Jesus, this is not good. Oh my god, what am I doing? Am I stupid? So let new example. Yep, should figure it out by yourself. So the example changed. Second, new example 5, result example, expected example. Man, hopefully it will be 17. If not, my day will be ruined. At least we have to wait to know. It's 0. What's the matter? Okay, looking good. So the second thing, let's print the grid here, since, I mean, we should do it like this. Why can't you be normal? So yeah, these are moving, but there are some bad things happening too. So we need only this thing, and we want only 5 iterations. Man. So, okay, it's 0, but we are not resetting the corners. What's up with that? So this is second setup corner. The setup corner, new grid clone. Why? Why would you do that? Can't we just use a mutable reference to that thing and just, you know, do this? And then we can get back the reference, and that's kind of it. Yes? Question mark? We want to mutate it. I don't know what happened with this whole cloning thing, but it should be pretty much the same. Yeah, it's looking good. It's looking better. Should be, I don't know. Cannot count it that fast, but yeah, it's looking better. What happened here? Whatever. Let's run the tests. Yeah, it's supposed to. Should be a little bit shorter, or should have been. And hopefully that's the correct answer, but we'll be failing at some tests. So it is that number. Let's rerun with this thing, and we should just try this number. It's too low. Okay, okay. It's something. What was the question again? After 100 steps. And it obviously won't be the same. Oh, Jesus Christ. Yeah. You will never know how privileged you are if you can read and write, not just like me. Yeah, so that's a different number. Let's put it here. Yeah, it should be better, and we should soon-ish be able to... Oh yeah, we have to wait 8 seconds. It was that number? That number, yes. Do it. Finally, yeah. I think that's enough for today, and yeah, meet you somewhere